tomorrow's needs is the motto of the Hawaiian Electric Company, which has been providing light and power for the people, business, industry, and institutions of Honolulu since 1891. Honolulu, and the entire island of Oahu on which it is located, is a growing, modern American community. In order to be ready with new light and power for this island when it's needed, Hawaiian Electric must constantly plan and build ahead. All stories must have a beginning, and our story started in the summer of 1956, when an important addition to the Hawaiian Electric Company was planned. These new units adjoin Hawaiian Electric's earlier Pearl Harbor plant, which you see in the concrete building in the background. The addition consisted of two 50,000 kilowatt units of the outdoor type on the shore of historic Pearl Harbor. The first outdoor unit, Waiau number 5, was completed in 1959. Construction of Waiau number 6 began 1 year later. Our story begins with the bulldozers, arriving to take away the overburden and to uncover the hard blue rock that forms the excellent foundation on which to build Waiau 6. The first step is the construction of the water tunnel, which carries as much as 55,000 gallons of salt water per minute to condense the large volumes of steam from the turbine. During the building, and before the tunnel was put into operation, it was tested by filling the tunnel with water and raising the pressure. This ensures a perfect seal between the pumps and the gigantic condenser. The concrete foundations beneath the turbine generator unit must be extremely strong and heavy to hold the machines in place while they are driven by the steam at a speed of 3,600 revolutions per minute. Daily tests of the concrete were made to ensure the required strength when cured. Samples of concrete were put into cylinders and crushed by large presses to test the strength of the concrete. All the steel was sandblasted to remove any trace of rust and then painted immediately to prevent corrosion. When the steel frame was partially completed, the mammoth steel drum for the boiler arrived. 185 tons of structural steel was needed to support the huge boiler, which supplies the steam to run the turbine. This drum collects the steam at the top of the boiler. It weighs 52 tons and is 33 feet long and 60 inches in diameter. The drum was unloaded from the trailer with heavy hydraulic jacks and stored on huge blocks until it was time to lift it into place. The drum was raised at a sharp angle to clear the structure. In place, the drum is supported by large U-bolts, 8 stories off the ground. Miles of tubing, like the pipes of a great organ, form the walls of the boiler. The tubes of unequal length were fastened into proper holes in the boiler drum. The large openings in the tube sections will later house the burners. Complex piping connects the boiler drum to the furnace walls and superheater sections to provide passages for water and steam through the boiler. After the steam has passed through all elements of the boiler and is at the correct temperature and pressure, the vertical main steam pipe is the outlet. The open spaces between the wall tubes were filled and sealed to withstand internal pressure and the heat in the furnace. A plastic material covers the finished boiler to provide a weatherproof coating. The 1,200-ton boiler is supported from the top of the steel frame, and provisions are made to allow for expansion when it is heated to operating temperature. Even the waste gases from the fuel burned to heat the boiler are put to use. They are passed through an economizer and an air heater to heat the incoming water and also heat the air for combustion in the burner. The 95-ton rotating element of the air heater turns 3 revolutions per minute. As the element rotates, heat is removed from the outgoing gases and transferred to the air coming into the furnace. Completed, the air heater provides 58,000 square feet of heat transfer surface. While the boiler was being completed, installation of the steam turbine began. This turbine, which drives the generator to produce electricity, has 2 main parts, the high and the low pressure turbines. The high pressure turbine expands the steam as it enters. The steam is then passed along to the low pressure turbine, where more energy is extracted. The leveling plate, to hold the low pressure turbine casing, was carefully installed to ensure perfect alignment. The bottom half of the low pressure turbine was installed and the rotor set in place. The lower casing of the high-pressure turbine was installed, followed by the high-pressure spindle and the high-pressure cover and steam chest. The heaviest single piece of equipment needed for Waiau 6 was the generator stator, which houses the generator coils. It weighs 88 tons, but in order to reduce the weight, as it was unloaded from the ship and transported across highways and bridges, the end sections of the stator were removed. It now weighed 77 tons. But even so, the only crane on Oahu capable of lifting it was the Navy's large hammerhead crane at Pearl Harbor. After being taken off the ship, it was loaded onto a heavy-duty trailer and taken to the construction site. Special permission was necessary to transport this tremendous load over public roads and bridges. At the job site, the stator was unloaded on special skids with rollers and skidded into position without being lifted. Special care was taken not to damage the coils of the stator or insulation on the surface of the rotor as it was installed. When all the components of the turbine generator are in place, the unit weighs 280 tons. Six burners installed in the front wall of the boiler complete the system. The main steam line connects the boiler to the turbine and supplies 485,000 pounds of superheated steam per hour to the turbine. After the steam has passed through the turbine, it is converted back into water in a large condenser. This condenser is installed under the low-pressure turbine and is fitted with 33 miles of aluminum brass alloy tubing. These tubes carry the salt water, which cools and condenses the steam passing over the outside of the tubes. When completed, the turbine generator is enclosed in a weatherproof house. And now the boiler was ready to be fired. The boiler was put through rigid tests and exacting cleaning operations, which included blowing the main steam line. This minimizes the possibility of damage to the turbine by removing foreign matter from the piping system, which might blow in with the steam. While the power plant was under construction, Hawaiian Electric was building a 138,000 volt transmission system, the highest voltage ever used in Hawaii. Electric power has its ups and downs. It comes out of the generator at 12,000 volts. This transformer boosts it to 138,000 volts. Then the substations take it down again to lower voltages for distribution to customers. Here you see huge transformers being installed in the 138,000 volt switching station. These take care of the first voltage change as the electricity leaves the switching station. Here the electricity is reduced in voltage and connected to the 46,000 volt switching station for distribution on other transmission lines. High tension towers like this one were erected through forest land and over cloud-covered peaks as another part of the expansion required to meet increasing needs for electricity. Electricity leaves the plant through large circuit breakers in the switching station to the 138,000 volt transmission lines, which carry it over 3,000 foot mountain ridges to substations at other parts of the island. And from these substations, it is delivered over lower voltage lines to homes and businesses. Hawaiian Electric power enters homes throughout the islands, enabling a higher percentage of residents to enjoy better living electrically. But our story is never finished due to the ever-increasing demand for electric power. It goes full circle as bulldozers move in once again to lay the groundwork for yet another Hawaiian Electric station in a rustic valley on the seacoast of Oahu, where many sister units are planned for the future. Even as this film is produced, the Hawaiian Electric Company is constantly striving to produce more electricity at lower cost for more people. And even now, studies are being made for the utilization of the miracle of nuclear power sometime in the future. It's another example of Hawaiian Electric's continuing process of building today for tomorrow's needs.